Welcome everyone to the Tulsa.net user group. Tonight, Chad Green talking on messaging patterns that's going to transform our cloud architecture. Chad, thank you so much for presenting tonight. I really appreciate this. And what you were saying, this is kind of a relatively new talk. Please take it from here.
Yeah, thank you. Yeah, so actually, well, the funny part is this is actually based off a workshop, which is also new for this year. And I was like, oh, this is some really good content. Let's turn this into also a, basically a mini version of the workshop. So definitely, thanks for having me. So Sean already did a really good intro for me, but there's all my contact information. Um, and I'll show that again. So, and a little bit of pimping real quick. Definitely events to check out. There's some really good events to come. I mean, so grant you, people are coming from all over the place, but nearby Tulsa would be like Dev Up in August and Kansas City also in August. Notice August all of a sudden got really busy. Actually, it's kind of weird because like this is my last speaking event until August. That's not normal for me. Yeah.
And just to plug you even more, you're helping with the Cincy Deliver conference that is also
Yeah.
early August.
Yeah, actually, thank you for reminding me of that again, because if Phil saw this slide, he would kill me. Because I keep on forgetting. Because I was going down my speaking engagements. I'm not speaking at Cincy Deliver. I'm just running it. All right. So what are we going to be talking about, over the next hour or so? That's, messaging patterns. I mean, the whole idea, I mean, I love this because I said, to master, or what did I say? Actionable insights. I did change it because I originally had like master, and I'm like, can't really oh, it's the next page. I got master, but talk about messaging patterns because we all have probably done messaging at one point or another. Messaging is kind of the life I live, but there's a lot more. It's not just sending a message to one place or another. You can just do that, but there's a lot more, and you get more benefit out of some things. So here was like the objectives, and I love how I put master core messaging fundamentals. We're here for an hour. You're not going to master anything in an hour. But what I hope is you'll hear things you hadn't heard of before, or you haven't at least heard of them in relation to, just into messaging. It'll spark, an interest to check out some more things. So as far as agenda, I mean, we're going through an introduction. I'm going to talk about some quick fundamentals of messaging. And then my survey of messaging patterns. That's the whole bulk of this talk. And in the end, I'm gonna go through a quick walkthrough, and then we'll have time for Q&A and closing remarks. Of course, most likely we'll have like one or two questions, and then we'll turn off the video, and then we'll have like 50 questions because I know how most user groups go when it comes to online groups. I'm the same way, so I can't fault that. The one other thing I do want to say about this talk is, so I am a Microsoft MVP. My specialty is Service Bus, but these patterns don't matter for the most part. What tools you're using, these can pretty much work in anything. I mean, obviously, some tools are only meant to do so far. Like if you look at like Azure storage queues, obviously they can only do so much. But the patterns are the patterns, all right? And I will say at that, when I do that quick walkthrough, I am using Service Bus, but only because I need to use something as a tool. So the fundamentals, first off, I mean, why does messaging matter, right? I mean, why can I not just make an API call, which is a very valuable thing, but there's, some things we can do when we add in messaging. Number one is the ability to do seamless communications. The whole idea of being able to send a message and then I don't care, right? It's, when I don't care what the system that I send it to does, I just need to go on the next thing, right? I mean, these are great things. Think about, different types of technologies, so, a prime example, so Jasper, we still have a lot of legacy code. And, that's part of what we're doing is we're using messaging. So we send a message off to Service Bus, and then we have a translator that converts things to what it needs to be in our super old systems, and sends off, right? So my brand new systems all they know is they're just sending a message. They don't need to know how the legacy system actually needs it. And then sure enough, I mean, APIs are great, but I mean, here we can do even more. You can get better collaboration with this. Next thing, and one of the reasons why I first got into messaging is scalability and performance, right? Because again, I can distribute the load. There's a whole pattern talking. The whole I drew a blank on the name of the pattern. I talk about it in another talk, but now I'm drawing a blank on the name of the pattern. But whole pattern is talking about just using queuing to help with distributing load and getting that scale out there. And we definitely optimize the throughput, because the big reason is because I can send a message very easily, and then I can let a middleware handle the actual work of getting the message off to where it needs to go to, and or the duplication or the filtering or the routing and all that great stuff. And then finally, bringing in reliability and fault tolerance. All right. So guaranteed delivery, that's a term we talk about in messaging. I think it's a false term. I use the term all the time, but guaranteed delivery means it's guaranteed to be delivered to the broker, right? If the receiver never picks it up, well, they never picks it up, right? So, but you do get some guarantees in there, and so we're getting some reliability with that. The persistent storage, being able to handle error handling, but also, again, think of what happens when that target system goes down. Well, your message queue can pick up that, and then when that target system comes back up, it can pick up the messages, and again, the primary system doesn't even know that it ever went down generally. So some key concepts, some things we'll normally hear. So message queue, all right. So basically the whole idea of that form of asynchronous service communication. All right, it's where the message goes into the holding place. The thing we always hear is the publish subscriber model, which I'm going to talk about a pattern behind publish subscriber. But generally, that's what most people, when they hear messaging, that's what they're thinking about. The whole idea, I publish a message off to a queue or a broker or a topic or something like that. And then, I have something that is subscribing to it and getting those messages. All right. And again, we'll see more of that here in a moment. Your message brokers. So these are your tools that you're using. That's that middleware. Usually these are very, very reliant, very, big time systems to handle lots of messages. I always laugh because, so manufacturing, or what technically we're remanufacturing, we're building a system right now, and when it's fully operational, we'll probably do 100 to 150,000 messages a day. And, talking to the chief financial officer who's in charge of IT and the directors, they're all like, oh, won't that be a lot? And I'm like, I know people who send 150,000 messages, if not, if worse in an hour, if not, a lot quicker, right? So I think we'll be fine, right? But but message brokers, provide that. Some of these include like Apache Kafka. Apache Kafka is kind of like the gold. I don't want to say the gold standard, but the de facto message broker, because like Service Bus and Amazon SNS are based off of Kafka. All right. For example, Service Bus right now, well, between Service Bus and Event Hubs, the Microsoft Message team right now has the goal of getting 100% compatibility with Kafka. They're like at 99 point some odd percent. They got like one more feature that nobody uses, but that's their goal, is to get to there. Transactions. So again, I mean, this is just like you normally think of the whole idea of, you start a transaction, hopefully have a way to back out of that transaction. I will say this: there are ways to do transactions. So for example, you can do what you normally think of a transaction, just like with a database transaction. I generally stay away from those because I find them more trouble than they're worth. But we'll talk about the Saga pattern near the end. And that's a great way to do transactions. You have to do more of the work on your own, but it's got, the patterns built to handle that. But definitely something important to think about. Dead letter Q, another thing that we'll talk about the pattern here, but because I know we all write 100% perfect code that never fails, but in the real world, that's not what happens, right? Things go wrong, and that dead letter Q is there to handle that when messages have problems. Send it over there so it's not blocking the pipelines. The other important thing to understand, and this is idempotence. And which it's funny, when I first saw the word idempotence, I could never figure out how to pronounce it. But now I use it so often, it's just second nature. But this is the idea that I should be able to do the same thing over and over and over and get the same result. Now, again, obviously, that result might be the actual values might be different, but I should always get the same result back in there, right? So, and this gets really important in messaging because a lot of times we'll see exactly that. We'll see a message come in multiple times because of because of one reason or another. Just the way how a system works, or so prime example, we've got we're working on a thing right now. So manufacturing planning, they plan out the work that the different groups within our manufacturing floor is going to do. And every time they reorder the items that the different groups are going to build, that sends over all the messages because it reorders the whole thing and it repopulates a new number. And that literally I could within seconds get the same message, right? Well, we want that to have the same response, right? Same, working out. And then FIFO, first in, first out. Most messaging patterns, that's exactly how they are, at least by very nature. Now, FIFO gets a little bit interesting, and the reason why I want to bring it up in here is, if you expect FIFO, then there's some things you cannot do, all right? And the big thing is we'll talk, if you talk about like adding Azure functions or, AWS Lambdas, the way how they work is they will actually, hit that queue like crazy. And so your messages won't necessarily be processed in order because you've got multiple functions or lambdas running. So things to understand. And then again, we'll talk about the sequence convoy that actually will ensure that you do FIFO even with large amounts of things coming in. So messaging patterns, these are just like regular patterns, right? And they provide a couple of things, right? Number one, we provide reliable and scalable communication, right? These are patterns we know that work, that that will do what you need to do. They help decouple components, right? Because and we'll see this. I've got nice graphics to help show this, but this is one of the big reasons why you use messaging is to help with decoupling your applications. So you're not having that direct connection, all right? It's going to that middle tier. And there are a lot of messaging patterns. And this was just, I went out one day and tried to find every messaging pattern I could find. All right, and I just spent I didn't spend too much time, but I spent a little bit of time putting this list together. So there's a lot. The ones here in green are your more key ones. And these are the ones that that we'll be focusing on today. And sure enough, honestly, if you understand these, you really are going to get the bulk of what you're going to need to do with messaging. So importance, I'm going to go through this a little bit more quicker. One, again, because these are patterns, right? So help with that, improving robustness, and then more importantly, handling real world challenges, right? So again, the first pattern I'm going to show is just a simple send a message over, and which is a real world challenge. But we'll see as we get more complex patterns how these help with things that really happen as you're building your applications. So all right, so our survey of message patterns. So like I said, I forgot how many I had in here, like 8 or 9 patterns in here, to talk about these. And again, there are, messaging is not a one size fits all. And you'll hear people say, "Oh, what's your favorite messaging pattern?" And of course, the answer should be, "Well, what's the problem?" Right? Because it really does depend, on the problem you need to solve as to which one to use. So the first one we've got is the point-to-point messaging, right? So this is the idea that we send a message from one sender to a receiver, right? So this is very straightforward. It's just simple message sending, right? So what does this look graphically? Well, first off, we've got our key components. So you've got your message producer, your sender, you have your message queue, and you have your message consumer, your receiver, right? So it looks somewhat like this. So your producer, so your main application, your primary application, you know, it will package up into a message that is agreed upon between the producer and the consumer, sends it off to this queue. And sure enough, if you know Azure, think of like Azure storage queues, right? This is exactly what you're doing in storage queues. And so, sorry, I just got distracted. Sean, of course, is going to send these oddball messages. But anyway, see, I am paying attention to the messages today. But anyway, so it goes to the queue, and then really simple. The consumer says, "Hey, give me the latest message," and it does what it needs to do. All right, lots of great benefits. Here, you really, you probably are more likely getting that guaranteed delivery. And again, the guaranteed delivery is that the fact that you've got something that's going to, do its best to make sure it gets out there. This is very simple. We're getting decoupling here, because you can truly see that I now am sending off to a third party to handle this. It's a great way to add load balancing. And again, think of where I can produce messages a whole lot faster. I just want to get them off and fire them off and then go off to the next task, right? Again, we can add reliability, gives it flexibility, also gives some control. Now with it though, partially because it's so simple, there are some drawbacks, although honestly, these are generally drawbacks with a lot of things. But number one here, scalability issues. I just have a simple queue. It's just getting messages in and processing as quick as the receiver can process them. So that can actually cause scalability issues. It is a single point of failure. Honestly, most messaging patterns technically are a single point of failure. But this truly is because it's just a simple fact of the way how it's working. Message ordering, right? Generally, these are in a FIFO manner. But again, if I was to do an Azure function in that queue, if that queue gets a whole lot of messages, then Azure functions or AWS Lambdas or GCP functions, they're going to do what they're supposed to do, and they're going to scale up and have more things come out, right? So, and we cannot guarantee the order of them. And then the one I always find funny is latency, because technically messaging is a latent process. But I also will usually get the, "Hey Chad, isn't this adding latency?" Actually, we had a architect who's no longer with our company, and he's so adamant. He's like, "Oh, doing all this messaging is adding it's calling all this latency." And I'm like, "What? 5 milliseconds? You're really worried about that?" Right? But technically it is. There is time it takes. Right? The messages can only travel at the speed of light. So anyway, some use cases. Think of like your job queues, your task scheduling, possibly order processing. Although this would have to be very simple order processing, right? So I mean those are your general use cases. So like I say, that's just your point-to-point messaging. So I mean the next one is your publish subscribe. So again, like I say, this is what we normally think about when we think about messaging. Generally when I hear people say they're going to use messaging, this is what they're talking about, right? And in this idea, I'm sending it to a topic. Now, topic is just another name for a queue. I'm not really sure why the pub sub pattern calls it a topic, but it does. I'm sure there is a reason. But at any rate, but the idea here is, and maybe why they differentiate this from a regular queue, is that I can have multiple subscribers. Now, I can also just have one. Actually, technically, I can have zero. Not very useful to send a message to a topic that has 0 subscribers, but that is very possible. But the more important part is I can have multiple subscribers. So, think of like a notification system where multiple systems need to know that something happened, right? Well, you can do that here, right? This now, but with that being said, that's not the only reason to use PubSub, right? Although I always tell everyone, if you ever think that you're going to have multiple, that you're going to need multiple subscribers, then you should go from the point to point to the PubSub model, right? Because there is no really overhead technically for you, um, but there is overhead if you then have to convert, right? Because obviously now you're gonna have to change the endpoints you're going to and you're receiving from, and so there's a lot of work. And again, I think we'll see how well this adds scalability. So here you have your publisher, so the app that's going to create that message. You'll have your topic, you'll have your subscriptions, and then you'll have your subscribers. And then overall, this, the message broker is providing that middleware, right? So your service bus, your Kafka, your RabbitMQ, whatever you're using, right, is providing that middleware, that message broker. So in here, I mean, this is still pretty simple. Publisher says, hey, I've got this message. Let me send it off to the topic. And then, again, we can see multiple messages coming here. The broker is going to say, okay, I'm just going to copy that message into all the subscriptions. All right. I mean, for simplicity, we're just showing 2, but this could be thousands of subscriptions. All depending on what you need. And then those subscriptions handle those messages independently, right? And they have their own checkpoints into what messages they have read. So, that first subscriber might have got ahead of the second subscriber, but that's fine. It will eventually work its way through, right? And it always ensures that they do get all of the messages in that queue. So some benefits now, again, that decoupling, right? And here I think we're seeing even better decoupling because now we're, because I can now have multiple subscribers. That's the next thing, the fact that I can have multiple subscribers. And like I said, like I mentioned, anytime you think that you're going to have the possibility, I always, I like to err on with caution and use this. And then definitely providing the scalability, flexibility, because most of the tools are providing this are meant for lots of messages. As far as drawbacks, I mean, a couple ones to hit upon. Complexity as compared to the point to point, right? Because now I have multiple subscribers. One of the issues you can have in here is, tracking what happens when things go wrong, right? Because now you got to figure out, well, where did that message come from? Who all received it, right? So that's where we're talking about with complexity. Another big thing to talk about is that subscriber dependency, because now, as you keep on adding more subscribers, the load on the message broker can increase. So, think of this, if you're trying to do like RabbitMQ that you're hosting on your own, obviously, eventually RabbitMQ is either going to need more resources that you're then going to have to plan for, or eventually, I mean, those tools are only meant to go so far, right? So you have to think about that. And then one other thing I want to mention here is the error handling, because as of so far, there's nothing to handle errors. What happens when an error happens, right? By the pattern. Now you could do things, on your own, but the pattern itself doesn't talk about error handling. That's something we have to think about, and we will talk about that here in a moment. So use cases again. Think about broadcasting that event. I just did something. As a system, I just did something. I know multiple people need to know about that. Another big use of this is your real-time data feeds. So something I built years ago. I was working for an education company, and we would routinely have like 20,000 people online at the same time taking these practice tests. And one of the things that they wanted to do was add real-time grading, and also be able to alert the professors, when Johnny wasn't doing so well, right? And it was actually a PubSub model that we were able to use, primarily because those tools were just more capable of handling so much things in real time. And again, alert system is another great example. Now this next pattern really kind of gets mixed in with other patterns, all right? And this is the idea of, well, how do I improve my throughput, right? Because so far what we've seen is, you have that subscription, you have that message queue, whatever it is, because a subscription is a queue, right? But I only have one thing attacking it at a time. So how can I handle it better, right? And I've been already been talking about, the way how like Azure functions and lambdas and so forth, how they will spin up multiple instances. Well, what they're doing is this competing consumers, all right? So the whole idea, and, I always thought this name was kind of funny because it sounds more aggressive than it really is. But the idea is here, you're just going to spit up multiple consumers to read those messages all at the same time, right? And get through those messages quicker, right? So we can handle those messages better rate. So graphically, you have your producer, you have your queue, you have your competing consumers. Again, you have your message broker. So that producer, it'll send its messages across and probably send a bunch of messages, right? Just this is where you're just producing a ton of messages all at one time, all right? Well, these computer consumers, the first one will pick up the first message, the second consumer will pick up the second one, and so forth, right? They'll complete their message and they'll get the next message, all right? So this is why you can see why messages aren't necessarily handled in order, because you know one of those processes might actually run faster for one reason or another. All right, and so they're not respecting the, okay, well, I have to wait till all until the order messages are processed. So again, if ordering is important, again, it's not that you can't do it with competing consumers, but it is something you have to think about. So benefits, I mean, scalability, right? I mean, now, again, think about like an Azure function or AWS Lambda, right? The whole idea of, I could spin up multiple instances to handle when we get a whole lot of load here, right? Handling that load balancing. We're also getting fault tolerance because if one of the consumers starts failing, well, that's okay because you've got other consumers to start handling the work, right? So that really does help. Um, so some drawbacks I talked about the message ordering, right? And again, and this is why usually one of my first questions when I'm talking to business owners or business, product owners and such, when they tell me, hey, we need to make sure that the messages are processed in order. My first question is, does it really need to be processed in order? All right. Or if they don't say anything, do your best, it doesn't matter, right? Because I need to know that. You'll have some, complexity and coordination, and mostly again because you can have multiple things happen at the same time. It kind of goes along with that message ordering. You can get resource contention. Again, if you're using some of the better tools, you're not really going to have that as a problem, but it is technically a drawback. Your use cases, your task processing, data processing. Think about where I need to process a lot of data all together. I can split it up in messages and have all these different consumers handle it at the same time. And order process, another great example of this. Where think of like that. I seem to keep on using Ticketmaster example in this talk, but think of like that Ticketmaster where Taylor Swift just won a sale, so now you need to be able to handle the 50,000 people that can fit in that stadium. They want to get their tickets and they want to get them now, right? Well, this can handle that type of need. All right, so the next two I'm going to talk about are a little bit different. I mean, they are patterns, but again, I mean, these are definitely things you use with the other things, and these really kind of enhance other patterns, although they're patterns in themselves. And the first one being filtering, right? So, basically, what happens when I don't want all the messages, right? Maybe maybe there's some reason why I only want some of the messages, and that could be because they're for different, there's different categories within those messages. It could be, well, so again, I'll use an example we're using at work. We're building this whole new manufacturing system, but we're not going to roll it out to the whole company at one time because we're not stupid. Like I said, this is a really big system with lots of changes. And, but I talked about that earlier. I talked about that message or that manufacturing planning system. It's going to inject a whole lot of these plans out to us. Well, we're going to filter that so we only pick up the areas that that is using this new system. So that's a great example of using filtering. Another thing is, you can read in your messages and find messages that are going to cause a problem, and you can start filtering those out. So graphically, looks very much like a pub sub model. It doesn't necessarily have to be a pub sub model, but this is not an unusual way of seeing this. So in here, we've got this message. It comes into the router and it says, oh, and it sees something in the message, right? Whether in the body of the message or a metadata on there, and says, oh, this is for subscription A, so I'm going to send this over to subscription A. Another message comes in, the router is going to say, oh, this is for subscription B, so I'll send this over to B. And again, I'm making this very simple. These can be very complex queries that you can use. And again, now those consumers will handle them, as they need. So some benefits here. Number one is efficiency, right? Think of, if as a consumer, I don't want all the messages, right? I only want a group of those messages for one reason or another. Well, this makes it more efficient for them because the router is handling that, right? And again, those routers are specialized to do this. They can definitely do this a whole lot more efficient. So, hey, buddy. My door doesn't close all the way, so the dog just it's like, I don't care, your door's closed, I'm coming on in. But these definitely be more efficient. And again, adding that scalability, but also flexibility, right? The idea that I can have, a system that produces a lot of different types of messages, and I can be flexible as to, well, only send certain messages to certain target systems. Your drawbacks, we're definitely adding complexity, especially, the filters could be very simple, also could be very complex, right? There is some overhead, but again, the brokers handle it for you. And actually, there is some scalability issues in here, especially if we got a high number of filters. You will see even the best brokers start to falter a little bit with that. So your use cases, subscription filtering, data segmentation, right? Again, like we saw that subscription A, subscription B, right? I'm notifying out there. Notification systems, maybe we have like we're sending alerts and we've got severity in there, right? So we can route it. So, oh, here, this is going to go in here because we're going to send it to these people, but but this is more important, so we're going to send it out to a different group of people. It's all right. Message routing. So this actually goes right alongside of filtering. But now, this is the idea of how do I route messages? So not just to different subscriptions, but actual routing. And that's the idea, right? It's directing messages to the different locations. And again, isolating those problematic messages. So graphically, we have that producer, we have our consumers, we have our endpoints, and then we have our router. So the message comes in, and in this case, this says, oh, this is endpoint A. So it sends it off to endpoint A. The consumer for endpoint A handles this. Comes in, endpoint B handles that. All right. So pretty simple, really, when we talk about this. But here's another, maybe better example of using routing. Here, notice I only have one consumer. All right. So, think about maybe we're constrained. We can only have one thing handle this, but we have messages and they have like a high priority and low priority, right? So in this example, the producer comes in, this is a low priority comes in. There was only one message in there, so the consumer got it and it handled it, but more messages came in while it was processing. Well, because we've got this routing, the consumer will say, hey, I'm gonna pick up messages from the high priority first. So when the consumer's done, it will get that high priority before it picks up the low priorities, even though those low priorities came in first, all right? This is a great way of handling those kind of needs, when you are restricted as to what the consumer can handle, all right? Because maybe, in this example, competing consumers, doesn't meet your need, or you have competing consumers, but you have so many messages, so you want to handle it, that type of way. So again, flexibility, scalability, improved organization. Right now, we can actually better organize where a message is going to. But this is, again, it's adding complexity. It is adding overhead. And again, that technicality that, we are hitting on scalability, right? I mean, while routing can help with a balancing load, if it's not properly, managed, it can become a single point of failure. So that's really the big issue when we're talking about scalability. Your use cases, again, that load balancing, your content route based routing, like we saw with that, the endpoint A and endpoint B, right? Maybe, so like we do a lot of shipping, and so, we want to send things to one API when it's going to be a US based shipping as opposed to a Canada based shipping, right? That's a prime example of content based routing. Or like we saw that priority routing, right? When we need the ability to handle priority in our messages. All right, the next one. So as I joked earlier, I'm sure everyone here, but not me, writes perfect code. It never fails, right? Your messages just go through every time, right? But in reality, that's not what happens, right? I mean, we have problems, and problems can come in all shapes and sizes, right? So how do we handle it? More importantly, how do we have a way so that our consumers don't get bogged down with messages that are causing some type of problem? And that's where dead letter queues come in, right? So this is it's a secondary queue, right? And the whole idea is, when I get that problematic message, I can isolate it and, and basically, and then handle it in a different way. So, so again, and this can be applied to lots of different types of patterns. But here we're just showing that point to point. So the message comes in, it reads it, the message works. So everything just goes fine, right? Well, the next, let's get more messages in here. They're processing along and it's going just fine. And here we go. Now we came to a message and something's wrong with this message, right? It's not in the format we expected. It's outside the parameters, whatever the case may be, right? And and so now we're saying, well, we can't we can't process this message. What are we supposed to do? Well, that's where the dead letter queue comes nice, because now I can say, okay, send it off to the dead letter queue, and then I can continue processing the other messages just like fine. And then now I have a manner to handle that at a later time. And it could be, the pattern doesn't talk about how you handle, the messages come in that dead letter queue. That just really talks about having that queue to put things in here. And this could be a lot of different things you can handle this, right? I've seen some systems where it's just real simple and you just reprocess them, right? Maybe every hour, hey, try reprocessing these, right? And see what happens, right? Because sometimes it's a point in time, right? It also could be, maybe you'll send, an alert when messages enter in here, and you'll have some type of administrator that's going to go look at these messages and, and do something with them, right? Another thing we'll see often with these dead letter queues is, sometimes messages only have a certain lifespan, right? It might only be good for 5 minutes, 10 minutes, 10 hours, whatever the case may be. And maybe your consumer is not able to handle it in that period of time. So that's another common use of the dead letter queue, where you'll have your TTL, your time to live. And maybe, so I set my TTL for 3 hours, but in the 3 hours, the consumer is not able to handle it. Well, it goes down that dead letter queue. And again, so that it makes sure to keep on process messages that are still relevant. Now, admittedly, if that's happening, you still want to have monitors on there, because if you have a lot of messages in your dead letter queue, the one thing you do have to remember is it's not a get out of jail for free card, right? I mean, you still gotta handle it some way so that you can handle it, so that you solve problems. So your benefits. Now I'm adding reliability into my messaging, right? Because now I have a way that says, when there's a problem, I can send it off, and my consumers don't get bogged down handling that. I'm now having a way to do troubleshooting, right? Because we're not just throwing away the message. We actually are putting it into a separate queue, so I can go look at those messages that cause problems. And then we're adding efficiency because again, we can allow the normal processing. And drawbacks, and notice I put a question mark when I said drawbacks. So there are some drawbacks, right? Complexity, because now I've got this whole other queue, and I mean that is a true thing you have to consider with this, because now I have to figure out what I'm going to do with that. You can have delayed processing. You can technically have data loss potential. But the reason why I put this as a question is, I mean, this is a way to solve problems, right? These drawbacks are not, these are good drawbacks. These are things that's like, well, it's a drawback, but these actually make my systems better. So use cases, error handling, right? I mean, it's the most obvious. I talked about the message expiry, when it's just no longer good. And again, having a way to monitor and troubleshoot, that's what we're adding here. And I will say a common pattern you'll see is, like what's very common in service bus is, hey, I'll send it to the consumer 3 times. And if after like the 3rd time it still fails or it didn't complete, is more importantly, then the broker automatically will send it over there, right? And that's all configurable, right? So it's not like you have to do it that way, because you could say never. I do believe, if I remember right, by default, that's what like service bus will do. Is if the message goes out 3 times and it doesn't get a confirmation, hey, I'm good, you can clear that message, then it'll send it off to the dead letter queue if a dead letter queue is set up. All right. So 3 more patterns left, and these are quote unquote the more complex patterns. But these are where I talked about, what's my favorite pattern? Well, it depends on what you need to do. All right. In this first one, I've talked a bunch about sequencing. Right. What happens, when order matters, right? Because there are systems where the order of things matter. So prime example, we're building a system. It's going to receive these messages, and it is very well likely that there will be times where we receive more messages than our thing can handle in the order it gets it. But we're doing event sourcing, the whole idea where we're actually saving the state with each change. So the order really matters. We need to make sure we do that in order. And that's where sequence convoy comes into play. So basically, this pattern ensures that my messages do stay in order, right? And that they, that we process them that way. And it will pretty much enforce the order. So you got 3 key components. You got your queue, you have your order key. So basically, what within that message am I going to use to say, hey, this defines the order of this, and basically what's looking at is what makes this unique amongst other, as a group of messages. So like a group ID type thing, or thinking like a partition ID is a good way of thinking of it. And then your sequential processor. So the thing is actually figuring out the order of things, right? So here, again, just showing a simple process, but it can come different ways. Producer sends a message. It's in that order key of A, right? So the message came in. Another message comes in. This is order key B, but we get yet another message in A. So when the consumer finishes, again, even though B came in first, that processor is going to say, oh, but I'm working on the A messages right now, so I'm gonna process A. I'm gonna finish that, and then I'll pick up the B. Right now, I will say, and I keep on saying, I'm gonna add another graphic in here. This is pure what the pattern is, but this is not exactly the way how we normally use this. Really, what we're really using this is we're really mixing this in with, usually with competing consumers, all right? But they're not really competing consumers. Basically, I'm creating a consumer for each one of the, so a what do I call it, an A and a B, message type, right? And then that is processing within that group to ensure that within that group that stays in order. Because honestly, usually that's what you see, But this can handle again, making sure that it stays in the right order. Yeah, inventory changes is a perfect example of this, right? Again, think about that Ticketmaster, right? You know, they want to guarantee that when you say I picked, you know, center aisle row 5 or whatever, right? That I get my seat because I ordered it first, right? So benefits, big one, that data integrity, because we're going to process everything in order. And so we're going to ensure that we get it in order, which gives us that consistency and gives me that reliability. Some drawbacks, you're going to see reduced throughput, right? Even with where I've got different consumers for the different groups of messages, there's still I'm still going to reduce that complexity, or I'm sorry, I'm going to reduce that throughput. So this is again why I usually talk with the product owners, and when they say, well, ordering is important, I ask them, how important is it, right? Because there is a hit. Now, when I say there's a hit, honestly, half the time you will never notice it, right? I mean, again, these systems are built to be super fast, right? So, but it is something you have to consider, right? It is obviously adding complexity because now I've got different things handled in different ways, and again, I have a potential latency, and even more so here. So order processing, event sourcing, right? Example I was just talking about a moment ago. Ensuring that my database gets those messages in the order it needs to get it in, so that I have I have that proper history. Another perfect example is workflow management. Where I'm getting, I'm a processor, I'm getting messages for different workflows that are going on. I need to make sure that those happen in order, because with a workflow, that's can be really important, especially if you spawn off but you come back in. You want to make sure you process in the appropriate order. Hold on one second. Let me. So we have two dogs. The big dog comes downstairs. The little dog is upstairs howling because mommy's outside. So, all right. So your request reply messaging. This is actually honestly a little bit newer to me, but this has actually solved some interesting problems. And think about, so far we've been talking about asynchronously messaging, right? The whole idea, fire it off, I forget about it. I don't care when it ever happens, and more importantly, I'm not looking for a response, right? But what happens when I need that ability to do decoupling, but I also need a response back? I need to know something happened, all right? Prime example, and honestly, I mean, I really just found out about this pattern not too long ago. And the reason why I found out about it was, we were going to build this thing, it was going to go off to a legacy system, and then we're going to have no way of correlating everything. And I'm like, well, why not? It's like, well, because the message goes off, we don't ever get a response. And I'm like, well, it's got to be some way to handle this. And that's what this pattern helps with, So here, this is where we send off the message just like we do before, but now, or most of it we did before, but now we're actually waiting for a response, right? So we're going to get back there. So now this is basically what I like to call asynchronous synchronous communication, right? So I'm using all the asynchronous methodologies, but because I'm getting that response back, it is a synchronous communication. So graphically, what this looks like, so I have my requester or my client. Different people call this a little bit different than the patterns. And what happens is I send this off to the request queue. So, and then there's a responder or server that gives us back, which will send messages to a response queue. And the important part here is the requester, generally the way how this works, the requester actually in their property says, hey, responder or server, here is the queue I want you to respond back to with the information I want. All right. So requester creates this message, sends off into the request queue with that, hey, send it back to this response queue. the server will handle, do what it needs to do, build up the response, send that response to the response queue, and now the requester can receive that response and do whatever it needs to do. It's a really nice way of looking at things. I don't know why I've got that there, but all right. So benefits. So like I said, the biggest one is now, that synchronous communication. I can have that. But think about your simplified workflows, where I do need to do workflow. I need a response, but I need to make sure it's distributed, right? Especially like if you're doing microservices, but you need that, you want to still have that ability to have that third party out there, all right? This provides that capabilities, right? Control and coordination is another great example of this. And like I say, getting decoupling while still having a synchronous type of communication. So some drawbacks. Number one is obviously scalability, because now I need two different queues and, we have to handle this. Latency is your biggest one, right? Because now it's not a fire and forget. I now have to wait for a response, right? And in theory, if I'm doing this over just doing a regular API call, there's a delay, all right? And the pattern just talks about this. There's different ways how you can handle that delay, so that, you don't just have a spinning icon or whatever, that maybe take forever. But, you have to think about that. So, there's more work in there, which kind of goes into, some of the complexity that gets added in here. Obviously, that does add to the resource utilization. And here, I really am talking about with that client, right, the requester, because now, that requester again, like I said, is somehow waiting for that response to come back. And error handling gets a little bit harder here because now, again, I got to wait for this, and this is technically a single point of failure, but again, I think it's acceptable that. So use cases. Service invocation is one of the great examples of this, right? Hey, I'm gonna fire off. I want that service to do what it needs to do, and then give me the response back. And that response might just be, "Hey, I'm done," right? Or, "Hey, I'm done. Here's the results," right? Data retrieval is another prime example of this. Think of where the data retrieval is a little hard, so you can't just do it in a single process. Or, again, in a decoupling method, um, the server, is the master of that data, right? And so let it know how to retrieve the data you need, right? And then using this type of stuff. And yes, to Smith's response here, right? You're having to wait, right? And you got to know how to do that. So I will say this: if you ever looked at Azure durable functions, this is actually what they're using, right? For a lot of the things, the way how they fire off, it is actually using a request reply system. And it's actually really nice because they've built in some really nice ways of doing that, but then having like a status page, so I can then go get my statuses of what what's going on with that request. I said 3. There was actually 4 when I said 3. So scattered pattern. This is another really interesting pattern. So think of when I need to send a request to a bunch of recipients at the same time, and then aggregate the values back, right? That's what the scatter gathering is providing. So I send it off to multiple recipients, and then I get the responses and I'll aggregate them, right? This definitely helps with parallel processing, right? So prime example, this is actually a vendor of ours is doing this. So I mentioned, Canada shipping, right? So Jasper actually owns all of its own trucks, right? So we have our whole fleet of semi trucks and delivery trucks and all that good stuff. But we do not ship into Canada for, because we don't want to deal with all the customs and all that good stuff. So we actually ship to our closest branch and then ship it to, have someone else ship it over the border. And one of the things we were recently working on was, okay, I need to go get rates. And so our vendor, we send them off this request, hey, here I've got a skid. It weighs this much. It's got, here's the size of it and all this good stuff. And then what it actually does is it then sends off the information to like 8 different, actually it's more than 8. I think it sends off to about 20 some odd different shipping companies. And it gets those rates and it sends back all the results to us, right? So that's a perfect example of this scatter gather. So Wes looks a little bit more detailed here. So you have your requester. So this is, the thing that's going to, basically request for information. You have your scattered recipients, right? So all the different recipients, and you're going to have a gatherer, right? So the thing that's actually going to say, okay, I'm going to receive all these things. So, well, this looks like requester prepares their message and then sends us off to the scattered recipients. Those recipients will process their get their, they'll do what they need to do. And then generally you're saying, okay, now send your response over to this gatherer queue. So then I have a consumer listening to that. It grabs all these messages, and then we'll do whatever it needs to do to aggregate that. Whether it's give me a list of all the values, pick the best one, add them up, whatever is needed for that aggregation. So your benefits, efficiency, right? I can now send one request off to multiple places and then get an aggregated value instead of that requester having to do that, and probably one by one, right? So it's going to be, it's going to be much more efficient. We're adding scalability, and we're also adding that resilience. Because again, if you look at the way how that pattern worked, if one of, generally, if I go back here, generally when we get things in this gatherer, right? Let's say I had 5 scattered recipients. Well, maybe I'll set a timer and say, hey, I'll wait for a minute for responses to come back. And if it, and after I'm going to go ahead and gather and aggregate, right? After the minute, whether I got all the responses back or not. So we're adding resilience in here, right? Because maybe one of those recipients are down, right? No big deal, right? We waited our time period. We said we were going to wait, and we got, we did or didn't get our response. As far as drawbacks, again, it's complexity, right? I mean, that's obvious, right? Now I've got messages going all over the place. So that's adding some complexity. And then, I mean, this is another case where you actually have latency because obviously you're waiting for all these responses to come back. So, going back to that one vendor, the one frustrating part about when we send those requests off, that API call takes between 45 and 90 seconds to come back, which means we have a screen just spinning, waiting for that, right? And actually, that team right now is working on how to do that because that's actually in the legacy system, and it doesn't actually like waits like that very well. So they're actually dealing with that right now. So you do have to worry about that. And again, that's one example. The pattern doesn't necessarily make it take that long. It's actually just because it's sending off to all these different things, and it's waiting a period of time. And I think actually I think they're purposely waiting for a period of time before they, so they're not waiting to see if all the responses came back. Oh, it's interesting. I've seen where it says, well, we need a response back in the time, right? Use cases, your parallel processing, data aggregation, and load balancing, right? So some great examples. All right, one more pattern to talk about, and that is the Saga pattern. So, so I talked about transactions at the beginning. The Saga pattern is what helps if you need transactions. And the Saga pattern, if you've heard of the Saga pattern before, it's the exact same thing. It is what with the same Saga patterns in the Gang of 4 book. That's what we're talking about. It's just we're using a messaging tool to actually implement the Saga pattern, right? So we're breaking down a process into transactions, to smaller independent steps. And and basically it helps us with these long running transactions. So in here we'll have our coordinator, we'll have our transaction steps, and then you have your compensating actions. So basically oh crap, it didn't work. How do I get back to a state, right? Because I probably have already changed some things. And then finally, I need state management, right? Because now I need to keep track of where I'm at and what has done, what has not done. So graphically, we've got our coordinator, our step queues, our consumers, and our acknowledgement queue. So the coordinator sends off the message to the first queue. You know, that consumer, that processing that transaction queue does what it needs to do, and then says okay, so sends it off to the acknowledgement queue, which the Saga coordinator is listening for. And it says, oh, I got that message back. I'm done with that step. I can now go off to to the next step. And and again, it'll just do this over and over until it's got all the steps processed. So what I don't show in here, and mostly because I got to figure out how to fit this all on the screen, is what happens when something goes wrong, right? So if we're in that, let's just say we're in that third step and it doesn't work, right? Well, that's where the compensating actions come into play. So now that your compensating actions need to know, how do I back out of the two steps that had completed prior to getting that third step because an error happened. So one of these days I'll figure out how to graphically show that and not have this mess of a PowerPoint can only do so much. So anyway, so your benefits. I mean, again, that data consistency, because now I have transactions in a sense, right? Not true transactions, because you're kind of managing it more, but we definitely have a way to do this better, right? I'm getting that fault tolerance because I have something that happened, to handle when things go wrong, right? And again, scalability. Your drawbacks, I mean, you're definitely talking about complexity. Anytime you have to deal with, with handling what happens when things go wrong, you've got complexity, right? Because now you have to think of all the things that have to happen, right? And again, in the proper order, right? And more importantly, how do you do that, and not have the compensating actions cause problems, right? Which goes right into the compensating logic, right? I mean, they're not easy to write. I mean, it sounds easy, but you have to think, they have to be bulletproof, all right? And that becomes a problem. Use cases, microservices is a perfect example of this, right? I'm going to do a workflow over multiple microservices, perfect example of this. You order processing, right? So you can have like, place order, update inventory, handlings and these different things, having them in, oh crap, we said it was available, but we got to fulfillment and it's not there anymore. Handling that, compensating, well, get refund the guy back and all that good stuff. Travel booking is another perfect example of this, right? Airlines actually use this a lot to handle, because it will happen. I've actually had it happen where I was booking a ticket, and then the time I booked it, the class that I was booking was no longer available. All right. Yeah, you're booking that. You're trying to get that first class ticket at the last minute. Actually, that's not me. I don't have fill money. And that's a joke that probably only one person in the group understood. All right, so real quick, I'm going to show this. I'm running a little bit long, but and actually the way how I built this was I said, hey, let's look at the last three, and we'll let someone we'll let you all pick what it is. The couple times I've done this, everyone wants to see the Saga pattern. So let's take a look at the Saga pattern real quick. And I'm not gonna actually write the code. I'm just gonna just open up a solution that's got all this written. And I'm actually not gonna run it because when I gave this a week ago, I actually had a problem. And I don't know if it's just the time or something just wasn't right, because it failed. It only failed one step. But and I honestly, I just have not had a chance, because actually since then my daughter got married, and so I was a little bit busy with that. But anyway, so first thing, what I'm showing here, and Sean, can you confirm you can now see my you can see Visual Studio?
Yes, sir.
Okay, great. So yeah, so what I'm showing right now is a JSON file. So one of the things that got added back in, I believe it released in, it was released in November, was the Service Bus emulator, which is a godsend. Anyone who deals with Service Bus, one of the hardest parts of dealing with it was the fact that you had to do even your local development. You had to go out to service bus to do this, right? Or I mean, I know people who would do like RabbitMQ locally and then move it over there. And I never agreed with that because I'm like, you know, you could have problems because it's a different tool set. So they released this. It's really nice. What's really cool about it is it's service bus, right? I mean, you're not. It's not like you're running something different. You are actually running a containerized version of service bus. The and basically what it's doing is it's putting in a container. They have restricted so it can only receive messages locally, and then it's got a couple other. You can only have I think it's 100 queues or topics. So there's some restrictions there, but for local development, that's just fine. The other big restriction, and I hope one day they actually get around this, but there's no UI for managing your topics and queues. So you do this in JSON files, which these are pretty simple to do. So here you can see I've got my JSON file. I just have it set up for the Saga pattern. And you can see in here, and I don't even name them. This is a little bit of elaborate naming sequence. I only do this because I built this again for a workshop where we're going to do a whole lot of things over the day. So I wanted to build this so it's easy to understand. At the end of the day, what you're looking at. But we can see. So I've got my order topic. I'm sorry, queue. I've got my payment queue. I've got my inventory queue. So this is obviously an order processing system. And so basically, get in the order, take the payment, update inventory, right? And then we have our completion queue. So again, go back to that graphic. You had the hey, these different steps are done. Sends over a message that says they're done, so the coordinator can then handle that. So the way how this looks, we got a couple things. So one, I've got this built out. So built out a simple service helper. Really, this is just so I didn't have to write the same code over and over and over. I should also say the other big caveat. I'm doing everything manually in here. This is just straight C# code using the SDK. Use Azure Functions in real world, right? But I wrote this so that you don't have to know Azure Functions or anything. I wrote this so it could be, you could be a Java developer doing AWS, right? And you'd be fine, right? That was the idea here. But some important things we see, right? We're going to create our service bus sender. We're going to create our message. We can see we're adding some application properties, so some custom properties in here. So basically, I'm telling it, hey, and I could have put this in the message body. You could do this different ways, but in this example, I was putting in the property so I can see, what services return it. So the order, the order, the inventory, the payment, what have you, and then what was it successful or not, right? So a simple flag. And then we're gonna send that message, and then in the console we're just printing a message, right? So we can see what's going on. And then you can see like these different services. They're all the same, other than this line here is the only thing that's different in between all these, right? Well, I guess this line here also, right? So the text is slightly different, right? But again, and and this is just regular console apps. But it's gonna create that client. It's gonna create the service bus processor. And then you see we're creating. It's using event handlers, so it's gonna have this process a message. So when it gets a message to process, it's just going to here it's just doing something real simple. I just put a comment into update inventory, and then we're going to complete that message. Remember, I talked about in the dead letter queue, and I talked about, hey, a common practice is if a message gets received 3 times and it wasn't completed. This is what we're talking about here. If I didn't complete this and I received it again and I received it again, right? Then it'll say, oh, hey, send it over to the dead letter queue. And then we're also seeing, hey, what happens on an error handler. And here, I'm just printing out a message, right? In the real world, you want to do a little more than just print out a message. But again, this will, this will not send off that completion message. And there is, if you noticed, when it's quickly in the JSON, there was like a timeout value, right? Wait this period, and then they'll unlock that record. So the order service, the payment service, like I said, other than saying the text differences are all the same. So if we look at the, well, first, we have the, a simple acknowledgement message comes in. So, and again, we're just here's our state management, tracking, hey, did we get the, where are we at on things? So we look at our Saga coordinator, and here we can see this, right? It's gonna start the Saga. It's gonna, and then, it's doing a wait. So it's just gonna send those messages and wait for those to finish. And then when they're done, move to the next step, right? So this one's very simple. Normally you would have some, some more logic in here, but, we wait for the acknowledgements, we get those, we do, we're waiting for this. We are handling the exceptions, which notice I'm starting that compensate logic if I go in exceptions, which in this one, it's just sending a message to revert. So it's not doing a whole lot here, but it's, again, giving an example. And then finally, the program is just going to fire off. I mean, this isn't doing much. So that's kind of really quickly of what a pattern, the Saga pattern in particular looks like. I will say this, let me get back to my slides. And, so I do have, so a couple things in here. Let me actually get past this. So one of the things, I'm just going to skip down to this. Actually, I'm going to come back to that. So that QR code actually is to the repo for this presentation. So something I don't normally do, but in this one, I actually do share my actual PowerPoint deck. I normally don't share that because normally my notes are for me. But in this one, I actually, I put a lot of documentation into the notes on each slide. So there's a lot of documentation there, but the labs I used to build that demo is also in there. And the lab was written up to be self-sustaining, right? So it's so definitely use that. And then finally, I'll come back to this if you didn't get that. But if you found this interesting, and you want to get some more, you want to get more hands-on, I highly recommend you look at either DevUp or TechBash. Sean, I'll come back to your question. Although really Sean's kind of leading me, he's kind of talking about leading me down a path there, talking about answer patterns. But so sure enough, I'm giving the all-day workshop version of this talk where we'll talk about these patterns, talk about some other patterns, but we're actually will, go through this and you're actually going to be building these for real. So highly recommend that. So Sean asked, what are the anti-patterns of messaging? Actually, I gotta admit, I'm drawing a blank at the moment just because I haven't thought about that for a while. I need to probably should add that in here. I'm drawing a complete blank. Yeah, not sending the message. Yeah, that would definitely be an added pattern. I gotta admit, Sean, you caught me. I am just drawing a blank right now. I'll have to think about that some more, about anti-patterns. That's actually if you'd have one service bus feature, what would it be? The one thing that comes to mind is, so, and they have it, but I'm not a fan of it, is transactions, right? The actual capability of doing transactions where I'm not having to do compensating actions and that type of stuff. And I say that there is actually transactions built in, and it does work. So don't get me wrong. It's not like it doesn't work. I just find it very complicated, and I would love for a simpler way to do that, right? Because sometimes the Saga pattern's a little bit more you want, because again you have to do everything on your own. Um, so that would be one thing. Um, some of the other things, for me, if where I've worked, Service Bus actually really has, not to say it's perfect, right? Um, but again, like I said, I've got a system that we're expecting 100 to 150,000 messages a day. That's not a whole lot when you come to Service Bus. So Service Bus kind of has really met my needs. Um, I will say one thing that has been annoying me just in the past couple of weeks. I've got a team that's new to doing messaging, and they're doing it. And one of the things they really, Jasper's really good about testing, and so one of the things that they really want to do was they want their QA person to actually inspect the messages that are going into the queue, and well, more importantly, into the topic technically. And so, which was fine. So we created another, what subscription for them, so they're not accidentally confirming the messages, and the actual target systems aren't working. But for a non-developer and person who never goes into Azure, right? The Service Bus Explorer built in to Service Bus, it's not that hard, but it's hard enough. And like one of the things that's really caused me pain, because it really seems to confuse folks, is they've got the whole so Service Bus supports two different ways of authentication. So they've got RBAC, like most everywhere else in Azure, and then they have their security tokens, right? Where it's a simple, basically a connection string, which actually you can do a lot with that. I've always appreciated the way how they did it, but I much prefer the RBAC. Well, once you turn on RBAC, you're not in default in the RBAC mode when you go into the Service Bus Explorer. And that's really annoying, right? I'm like, well, if I turn on RBAC and I turn off the SAS encryption or policies, then go to RBAC by default, which then ties into, and there is actually, there's a open source Service Bus Explorer which does not work with the local emulator, and that's actually a really nice tool, and I really like it. But what was the reason why we're not using it? There was a reason. Oh, I think it's not, and I might be wrong about this, but I think it's not supporting the RBAC authentication. I know it's not. Yeah, that's exactly what it was. It currently does not support the RBAC authentication, and that would have meant I would have had to give regular people connection strings, and I'm like, yeah, that's not something I want to do. So either love for the team to either help out the Service Bus Explorer, the open source one, or come up with their own. Well, no, I'd rather them help out the open source one. Which, and that being said, the messaging team is they're I think they would actually prefer that too, to help out the open source project over not helping out. Let's see here. Couldn't we just send an event message to all the involved services, telling them when a given transaction failed and let them handle it instead of having, okay. So Max is, talking about the Saga pattern, talking about the compensating actions, and basically what Max is saying here is, hey, could I not just send it off to those services? Yes. And honestly, that's normally the way how you're handling it, right? Because again, that should be distributed work. The coordinator shouldn't know exactly how to do the compensating actions. It should just know that it needs to do those compensating actions, right? But again, that's still, Max, you're dead on the way how you're supposed to do it. Not and actually, you remember in the when we go back to this, that is what this coordinator is doing, right? I mean, in a very simple, it's not actually doing anything, but you notice I'm actually sending the messages um, back. Um, and actually, I just noticed that, I mean, again, this should have better logic to say, which one failed and which one didn't fail and so forth. Because obviously, like if it was if this one never ran, it shouldn't even ran. That's a little bit of error in my code. But so no, you're dead on the way how it should have it should work. Because and again, as some know, I'm a very big fan of microservices, and I'm a definite believer that the service should handle its own work, right? And it's the master of its domain, and it should be that way. So, any other questions? Well, awesome. And again, when Sean stops the recording, I'm still going to be sticking around. If Swanee, my wife's like, "Oh, do you want to eat afterwards?" I'm like, "No, not with this group." I spent many late nights with this group. So that, Sean, thank you so much.
Thank you, Chad. I greatly appreciate it. This was a great talk. I've already got one comment about this and was already looking forward to the recording. So I'll place that in chat is the record where you will find this recording after I am done editing, the youtube.com at Tulsa Denug. And there you will find this this talk when I'm done editing, plus many others. Chad, thank you so much. I greatly appreciate it. This was a fantastic talk, and I actually had no idea there were that many messaging patterns.
Yeah.
I was surprised by that. So I've already used and was aware of it, probably a handful, but that I was surprised at how many there were. So that was awesome. All right, last chance for questions. If you would prefer to wait a little bit, that's fine. Everyone is welcome to stay on after the recording has stopped, and we will have other comments, questions, discussions, whatever you guys would like to do.